Welcome back. We continue our discussion on irritants, or more specifically, lacrimators or simply tear gases. In the last video, I successfully built a small tear gas grenade based on chloroacetophenone, also known as CN gas. It worked well, but CN gas wasn't the first irritant I synthesized for this purpose. Take a look at the structure of this compound. It's a diamine derivative made from glyoxal and tert-butylamine. Notice anything suspicious? I didn't suspect anything either when I first looked at this formula. Nevertheless, it turns out to be a very potent irritant. It's even patented. Here is the patent. These two substances are patented as potential tear gas agents for police use. However, these compounds are relatively obscure and neither ever found practical application. I decided to synthesize this compound because it is very simple to make from glyoxal and tert-butylamine. I cannot give the exact protocol here, but in broad strokes you simply need to mix these two compounds while cooling. The product precipitates very quickly out of solution. I isolated the diamine as a white crystalline solid. It's poorly soluble in water, but dissolves readily in most organic solvents. The patent claims the substance is non-toxic, which is a good thing. This compound is quite volatile, much more volatile than chloroacetophenone. Attempting to work with it indoors without robust ventilation is a disaster. Its vapors very quickly cause an intolerable level of irritation. The effect is much stronger than when working with chloroacetophenone, though I doubt it's actually a more potent lacrimator. I believe the intensified effect is solely due to its significantly higher vapor pressure. The flip side to this high volatility is that if the diamine crystals get where they shouldn't, they will evaporate relatively quickly. This is a big advantage over chloroacetophenone, which can contaminate surfaces for days or even weeks. Naturally, I tried to turn the diamine into a tear gas grenade. Here is the video of its test. I used an ammonium nitrate-based pyrotechnic mixture for the sublimation, the same one I successfully used for colored smokes and for the CN gas. But when I walked into the smoke cloud, I felt zero irritation, absolutely none, not even a slight sting. This suggests the substance is thermally unstable. Instead of cleanly sublimating into the smoke, it simply decomposed under the heat. Perhaps this thermal instability is the main reason why the patented compounds never found widespread use. They cannot survive the sublimation process and therefore cannot be deployed using typical smoke grenade devices. Nevertheless, I think this diamine could still find application in the form of a pressurized spray. That's all for today. See you next time.